All right, good morning, welcome back. For today's lesson, we will get into, so we just drew a whole bunch of ions, and so we've drawn single atom ions so far. These ions that we've drawn represent what each of these elements do. So for example, when aluminum makes an ion, it will always lose all 3 electrons. It will always have a charge of +3. If someone says an aluminum ion, you don't even need them to say anything else because you are 100% confident that that aluminum ion must have lost all 3 electrons and have a charge of +3 because that's the only thing aluminum does. Same thing with calcium. A calcium ion means it's lost 2 electrons and has a charge of +2. An oxygen ion has lost 2 electrons and it's gained 2 electrons and has a charge of -2. Like, everything that you've written on this page is the only thing that that atom will do. And I'm saying that in part because where we're about to go, sometimes folks ask me, like, oh, wouldn't it be really convenient if this atom suddenly, like, what if aluminum only lost 2 electrons? Wouldn't that be really handy? No, that's not a thing. If you find yourself thinking that, you're not alone. That's, like, no worries, totally cool. But each of these things always does exactly what we've got written here. And if you find yourself thinking, like, oh, wouldn't it be handy if it did this instead, I will show you what to do in that case. But what it means is that your question is not done yet. That was a kind of wild intro. What we are doing today is we are going to draw ionic bonds. And we're going to draw ionic bonds. We're also going to go totally nuts. We're going to write the name and the formula also. Okay. This seems like a lot to do in a single day, but don't worry because we'll get it. Okay. Key ideas to ionic bonds. Some atoms lose electrons. Some atoms gain electrons. When an atom gains or loses electrons and becomes an ion, the electrons do not simply fly to outer space. They go stick to something else. When atoms gain or lose, every atom, let's write it that way. Every atom that, how do I say this? Every time an electron is lost by one atom, it will be gained by a different atom. Anytime, when, I should have thought this through before pushing play, because I have to rethink it every year. Basically, your idea is you're going to connect the arrows so that every atom that loses an electron gives it to a different atom, and every atom that gains an electron has gained it from an atom. Floating charge is, like, not a thing. So let's write this and then we'll talk about what does not. This is what happens, then we'll talk about what does not happen. Anytime an atom loses an electron, it is gained by and I'm writing atom, but really once an atom loses an electron, it is then an ion. And so the point it has been gained by a different atom, that atom is then an ion as well. So it's kind of, we're looking at that, like, momentary exchange moment where, like, your atom is losing an electron and a different atom is gaining the electron. As soon as this exchange occurs, they are both ions. But this is kind of like when your sodium hits the water and then it explodes, like that moment of exploding. You've got an atom turning into an ion and a different atom also turning into an ion. So they always go in pairs. So anytime somebody loses, somebody else gains. anytime an atom gains an electron and becomes an ion, it is lost from okay. Right. And this makes sense. For something to be lost, it needs to be gained. For something to be gained, it needs to be lost. Build up of charge is very uncommon because it's unlikely, basically. In the wintertime, you sometimes get like static shocks. That's like a super small amount of charge buildup that causes that shock. Lightning is a somewhat larger amount of static buildup, but typically we go through a lot to reduce or prevent static buildup because it conducts electricity kind of randomly, and that can be a really big problem. So if you're into anything about like computers or like internal machinery stuff, we go through a lot of hoops to prevent static buildup. And I mean, you get shocked by it, right? Because now you're conducting electricity through air, and air doesn't want to conduct electricity. Okay, anyways, so in terms of forming bonds, the overwhelming, except for static shock, everything is, when an atom gains, a different atom must have lost. If an atom loses, a different atom must have gained. Okay. That's the end of the lesson right here. I should just, yeah, great.